Let us look at the quadrature. Now, what does that mean? The ancient Greek meaning is constructing a square with the same area as a given figure. Whereas in calculus, it means finding the definite integral. Let's take an example. Given f of x equal to x cube, find the area between x equal to 1, x equal to 2, f of x and the x-axis. See, all this we have been doing it in the last so many sessions. Area is equal to the integral of x cube dx from 1 to 2. Pretty straightforward. And we know the integral of this, that is a is equal to x to the power of 4 by 4 from 1 to 2. Substituting the endpoints, we get a is equal to 2 to the power of 4 by 4 minus 1 to the power of 4 by 4, which gives us 16 by 4 minus 1 by 4, which is equal to 15 by 4. How does this graph look like? I'm sure you are familiar with this. Let's see. This is the graph of x cube, but we are interested in from x equal to 1 to x equal to 2. That is the boundaries. Now, x equal to 1 and x equal to 2 are vertical lines. So, let's draw those lines. And these lines pass through A and B. So, now here the A is at 1, B is at 3, but we want at 2. So, let's bring it to 2. So, what we were looking at was this area. This area is equal to 15 by 4, whatever be the square units. Let's look at another example. Y is equal to x square minus 4x. Find the area between x equal to 1, x equal to 3, the curve and the x-axis. Okay. So let's first look at how the graph looks like. So this is the graph of x square minus 4x. We want vertical lines x equal to 1, x equal to 3. So let's draw the lines. This is A, this is B. So the area that we are interested in is between these two lines, the x-axis and the curve. So this area we are interested in. Again, we know A is equal to the integral of x square minus 4x dx from 1 to 3. We can split this into two integrals. So A is equal to integral from 1 to 3 of x square dx minus integral from 1 to 3 of 4x dx. Integrating it, we get a is equal to x cube by 3 from 1 to 3 minus 4x square by 2 from 1 to 3. Substituting the limits, we get a is equal to 3 cube by 3 minus 1 cube by 3 minus 4 times 3 square by 2 minus 4 times 1 square by 2, which gives us 27 by 3 minus 1 by 3 minus 36 by 2 minus 4 by 2. So 26 by 3 minus 32 by 2, which gives us minus 22 by 3. Now we could have simplified it here itself and reduced our multiplication effort. Okay, anyhow. But now we have ended up with a negative area. Of course, it is going to be negative because it is below the x-axis. Areas cannot be negative. So we take the absolute value of what we have arrived at to give us area is equal to 22 by 3. Now this problem is a little bit different. We have x cube plus y cube is equal to 3axy. We have to find the area bounded by the curve itself. So let's try to figure out what's happening here. Let's convert it into polar form. So x is equal to r times cos theta, y is equal to r times sin theta. So applying that here, we get r cube times cos cube theta plus r cube times sin cube theta is equal to 3a times r cos theta times r sin theta. Okay. Now, here if you notice, r cube is common to both the terms on the left hand side. And on the right hand side, we have r square. So r cube and r square cancel out to give us r on the left hand side. So r times cos cube theta plus sin cube theta is equal to 3a cos theta sin theta. So which means r is equal to 3a cos theta sin theta divided by cos cube theta plus sin cube theta. Now let's figure out the zeros. So we apply some standard values to figure out these zeros. So let's try theta is equal to 0, which gives us 3a cos 0 times sin 0 by cos cube 0 plus sin cube 0, which gives us 3a times 1 times 0 by 1 plus 0, which is equal to 0. Okay, so that is one of the zeros. Now let's try pi by 2. So if theta is equal to pi by 2, then we have 3a cos pi by 2 times sin pi by 2 by cos cube pi by 2 plus sin cube pi by 2, which gives us 3a times 0 times 1 by 0 plus 1, which is again 0. Now here what is happening is, first of all, if we interchange x and y, the equation does not change. That means the equation is symmetric across x equal to y. So here, instead of x, we put y. If we substitute y with x with y and y with x, the terms remain the same. So that means the equation is symmetric across x equal to y. Since r is equal to 0 when theta is equal to 0 and comes back to 0 when theta is equal to pi by 2. That means what? It forms some kind of a loop which is symmetric to x equal to y. So we are trying to figure out the area of that is encompassed by that loop. So let's see how this graph looks like. It looks like this. So here, now let's take 2 points and draw the radius vector between those 2 points. So we start with both of them at the origin and we start moving it on the curve. So as we go through the entire loop, we come back to the original point. We have to figure out the area of this loop. Let's see how we do that. Area enclosed by the loop A is equal to 1 by 2 times the integral r square d theta from 0 to pi by 2. Try to figure out how we arrived at this. So using this formula, 1 by 2 times the integral from 0 to pi by 2 of 3a cos theta times sin theta by cos cube theta plus sin cube theta d theta. And we have a square here on top of this. Let's take care of the squaring. So 1 by 2 times the integral from 0 to pi by 2 of 9a square cos square theta times sin square theta divided by cos cube theta plus sin cube theta square d theta. Now let's open up the bracket, the squaring of this. We have cos to the power of 6 theta plus sin to the power of 6 theta plus 2 times cos cube theta sin cube theta d theta. Now to simplify this, what we will do is we will divide both the numerator and the denominator by cos to the power of 6 theta. So what happens? Let's see. We already have cos square theta. So if we divide the numerator by cos to the power of 6 theta, we get cos to the power of 4 theta in the denominator. And the cos square theta cancels out. And that cos to the power of 4 theta, we split it into 2. Cos square theta, cos square theta. So that is the numerator. Now in the denominator, cos 6 theta by cos 6 theta is 1. Sin 6 theta by cos 6 theta is tan 6 theta plus 2 times. Here again we are dividing it by cos 6 theta. So cos cube theta cancels out. And in the denominator of this, we have cos 3 theta. So sin 3 theta by cos 3 theta gives us tan 3 theta and d theta. 1 by cos square theta is sec square theta. Sin square theta by cos square theta is tan square theta. And this we can write it as 1 plus tan cube theta square. Let's briefly open it up and see whether it matches. 1 square is 1, 2 times tan cube theta plus tan to the power of 6 theta. So which is what is the denominator here. To solve this integral, let's do substitution. Let t is equal to 1 plus tan cube theta. So when we differentiate it, we get dt is equal to derivative of 1 is 0. Tan cube theta is 3 tan square theta sec square theta d theta. And that 3 we take it to the other side. Now theta is equal to 0 means if this is 0, tan theta is 0, that means t is equal to 1. When theta is equal to pi by 2, that time what will happen? This is sin theta by cos theta. Cos theta, cos pi by 2 is 0. That means denominator becomes 0, which means t becomes infinite. So our limits changes. And substituting, we get 9a square by 2 times the integral of, instead of 0 to pi by 2, we have 1 to infinity of sec square theta tan square theta d theta is dt by 3, and 1 plus tan cube theta is equal to t, and since there is a square here, we have t square. This is equal to, now here 3 is a constant, so we take it out. So 3 3 is 9. So we have 3a square by 2 times the integral from 1 to infinity of dt by t square. 1 by t square integral is what? It is minus 1 by t, and the limits is from 1 to infinity. Substituting the limits, we get 3a square by 2 times minus 1 by infinity minus 1 by 1, which gives us a is equal to 3a square by 2 times 0 plus 1. So that finally we get the area is equal to 3a square by 2. That means the area enclosed by this loop entirely depends on A. So that was quadrature. If you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.